talk about what happens with dependent events. So if events A and B are dependent, meaning the probability of the first does affect the probability of the second, then the formula, you find the probability of A and then the probability of B given that A already occurred. So this is the probability of B given A. So here we can write this out, that the probability of B given A means that the probability of event B occurring after it is assumed that event A has already occurred. So notice, whenever you see the words without replacement, dependency is implied. So our first problem here says, at one point in American history, there were 87 men and 13 women in the U.S. Senate. 3 senators are chosen at random to be on a special committee. The situation is dependent because once you pick the first person, there are only 99 left. So as you choose people, you can't choose them again and the probability changes. So we're going to write this out and say, once you pick the first person, there are only 99 people left to choose from. The denominator changes. Okay, so if we want to find the probability that all 3 senators are women, we want the first to be a woman, the second to be a woman, and the third, and we'll be multiplying. So the first person to be chosen, there would be 13 women out of the total. We had 87 and 13 of 100 people. Now the probability that the second one is also a woman, well, now there are only 12 women left over 99 people left. And the third one, there would only be 11 women left out of 98 people. And when you multiply this, when you multiply 13 times 12 times 11, you get 1,716. In the denominator, you'd have 970,200. And when we reduce this, we get our final answer of 13 out of 7,350. So it'd be a small probability that you'd get 3 women. Okay, we're going to look at 2 more situations. So 2 says that there are 5 colored dice in a bag, 3 red and 2 green. So 2 dice will be chosen without replacing them. So you're not putting them back in the bag. And that's what makes these dependent. So we want to find the probability that both are red. So red and red. So the probability that the first die being red, there are 3 red out of 5 total in the bag. Now we have to assume that we already picked out a red one, which means there's only be 2 red ones left. And there'd only be 4 balls left in the bag. So multiplying this, we'd get 6 out of 20, which reduces to 3 out of 10. Okay, so similarly, we want to know what's the probability that the first die is green. So here there are 2 green ones out of 5 balls in the bag. And the second one is red. So there's only 4 balls left, and we've taken out a green one, which means there's still 3 red ones. So we'd have 3 over 4. So here we'd get 6 out of 20 again, or 3 out of 10. Okay, one last problem here. So it says, from a standard deck of playing cards, find the probability of picking a king of hearts and then a jack of hearts without replacement. So there are 52 cards in the deck. And so for our first one, we want to pick a king of hearts. There's only 1 king of hearts. Now, we're not replacing it. So the next one, there's only 51 cards left. And there's only 1 jack of hearts. So multiplying these, we'd get 1 out of 2652. Okay, the next one says picking a king and then an ace without replacement. So first picking a king, so there would be 52 cards in the deck, and there'd be 4 chances to get a king. Now we're going to assume that we've pulled a king out. There's only 51 cards left. and we want to know the probability of getting ace, well, there'd still be 4 aces left. So multiplying this, we'd get 6 over 2652, which reduces to 4 over 663.